Oh, we're going to kind of transition to flood things, to what happened after the flood, the Ice Age. Only the biblical worldview can explain it. And by the way, I hope you have a sweater or a coat, because when I talk about this, people kind of get the chills. Okay, let's continue on. First of all, let's define what an ice age is. It's always good to define terms like what is evolution, what is science. When you define your terms, you find out that things that appear to be scientific aren't. Anyway, an ice age is essentially a great increase in snow and ice. Not very profound. Right now, 10% of the continents have ice sheets, mainly Antarctica and Greenland. 30% were glaciated during the Ice Age, mainly in the high and some areas of the middle latitudes and the high mountains all over the earth, even in the tropics. The snow level was down about 3,000 feet lower than it is now in the tropical mountains. So it was a global phenomenon. Also, I'm going to come back and revisit, it's the last major event in Earth history. You see, they're always challenging us, saying, you don't have any evidence from your worldview. And we're going to test that idea on the last major event in Earth history, which was the Ice Age. So we'll find out. Now, they claim there have been 5 ice ages throughout geological time, some going back billions of years, like in the mid-Precambrian, around 2,000 million years ago, 2 billion years ago. And here's the dates and the times of these 5 ice ages. So, I've come to believe that the real ice age is up here in the secular geologist Pleistocene time, but only part of it. These other 4, what's the evidence for that? Well, they do have some evidence in the form of, they find what they think is glacial debris with rocks inside of with a finer grain matrix around it, floating rocks in the sediments you might think of. And they sometimes have scratched bedrock and scratched rocks. So, how do you account for those things before we get into the real ice age? Well, the long and short about it, I discovered that the Pleistocene Ice Age is real, but only the last one in their scheme. See, they have multiple ice ages. In fact, they've gone from 1, when the Ice Age was first discovered. In fact, the Ice Age was a powerful evidence against uniformitarianism, because there's no ice sheets over Canada right now, and over North America and down into Central America, down to the cities of Kansas City and St. Louis. So it's against uniformitarianism, which is present processes. So it was a challenge to the uniformitarianism starting in the mid-1800s, as soon as it became an official doctrine with Charles Lyell's publications of the Principles of Geology, 1830 to 1833. But I discovered that the other 4, what's called pre-Pleistocene glaciations, can be explained by gigantic submarine landslides during the flood. And I wrote a book, I think clear back in 1993, Ancient Ice Ages or Gigantic Submarine Landslides. It's a rather detailed book, but I believe I made a good case explaining all that data that they claim are ancient ice ages that are in the hard rocks. These are right in a cliff. You'll see some of these things. So anyway, let's get to the challenge of the Ice Age. See, they challenge us on it. They say each Ice Age, now, like I said, they went from 1, and then they went to 4, and nowadays there's 50 of them, all in 2.6 million years, repeating regularly. Each Ice Age takes 100,000 years. The glacial phase is 90,000, and the interglacial phase is 10,000. And the Ice Age period is continuing. There's no reason for it to stop. We're in an interglacial right now, waiting for the next Ice Age, I might add. And this interglacial's got the name called the Holocene. And Arthur Stroller, that atheist, in that challenging atheistic book, which I thought was full of research projects, says, increasing the duration of the Ice Age by a factor of 10 greatly increases the stress upon the creation scientists and was compressed the events of 15 million years into 4,000 years of post-flood time. Well, what in the world is he talking about? Well, they decided one day that the Antarctic ice sheet, instead of forming during their Pleistocene time, or maybe a little before, they dated it 10 times as old suddenly because it had to match other features they found like on deep sea cores around Antarctica that they dated differently. So it started about 35 million years ago to build up, and then 15 million years ago, it reached steady state, and it's been generally the same height for 15 million years. So he says that puts a lot of pressure on us to accommodate all that stuff. Well, we'll check him out. This guy is an anti-creator. The whole book is a thick book against creationists. And this guy did his homework. He actually read a lot of our material. Now, we have some biologos type people that Kevin was talking about, and Reasons to Believe by Hugh Ross. And these guys who write books against our position, and you look in the references or the bibliography, they hardly reference our material. And we've been doing research for 60 years. And we have a ton of material out there that they can reference, but they don't reference hardly any of it. And if they do, it's some old book that's pretty old, that's got some good stuff in it, but, like every old book, things change and need to update it. That's how science works. So some of these guys didn't do their homework. So here's a challenge. What do I do with challenges? I apply 1 Thessalonians 5:21, the New American Standard Bible, I believe, says it the best. Examine everything carefully. You got to do it carefully. You got to go beyond the superficial level. Because if you stay at the superficial level, you might know just enough to get in trouble. But you hold fast to something, to that which is good, the Bible. Jesus is my Lord and Savior. And then from then on, I examine. This is what I've been doing for 40 plus years. So I'm going to kind of explain all this by a series of questions. The first question I want to ask was there really an ice age? Am I trying to explain a phenomenon that occurred during the flood and is not from the ice age? Well, where do we go to check all this out? Well, we go to presently glaciated areas today. And, here's a glaciated area, and they this is a valley glacier coming out, flowing out, and they leave these ridges around them. This is on the sides of the glacier. They're called lateral moraines, like right in here. And then in the front, it's called a terminal moraine. So the glacier pushes out, it moves all this debris out, it melts back, and it leaves debris. And here's another one, Athabasca Glacier in the beautiful Canadian Rockies. And it was out here in 1890. And practically all glaciers in the world are retreating due to global warming. And unfortunately, I couldn't give a talk on global warming or that evolution isn't a fact to the young people. But you can get a DVD out there, me giving a talk on it. I think it's probably 12 years old now, but the data is still good. The numbers have changed a little bit. But what you see around here is a terminal moraine. That's right, my cursor doesn't work. Terminal moraine right in here, and these lateral moraines right in here. And I took this 40 years ago when I was young and stupid. want to climb up on these glaciers. They're full of crevasses. Anyway, you look at the lateral moraine. Look how sharp it is. And you see some of the material in it. It's boulders and cobbles and sand and clay all mixed together. That's the typical glacial feature. It's called glacial till, T-I-L-L, in Ice Age jargon. And then some of the rocks are scratched. See, as the ice moves, there's debris in the bottom, picks up debris, and it scratches that debris. And sometimes the rocks shift the bottom, and they can scratch them in different directions. Like in this boulder right here, you got one going that way, some going this way, and some going this way. So at least 3 directions of scratches on it. But then as it's moving, it scratches the bedrock in the direction of motion, called a striated pavement or striated bedrock or scratched bedrock. So those are features we see around current glaciated areas today. Do we see those things in areas that are so warm that no glacier would survive the summer? Indeed we do, right here in Montana. This is just west of Augusta, Montana. You're looking at the Rocky Mountain front, and here's a mound of debris on the flat plains, like this. And it comes over here, and of course, it's not here. Thanks. Anyway, here it is. And look at the rocks on it. You have rocks on top of them, erratic boulders. And here it continues over here. And it broke through here. And of course, that's where they put the reservoir for Augusta and other places. I think it's called Pishkin Reservoir, if I'm not mistaken. And so you have and then when you look at the moraine material, this is what you see. Rocks of all sizes in a finer grained matrix. This is the typical glacial till feature in that moraine, indicating that that's a glacial moraine that came out of the Rocky Mountains about 10 miles out into the plains. And some of the rocks are scratched in different directions. And then when you climb up on the first cliff in the Rocky Mountain front, by the way, since the rocks are tilted down to the west, you climb up the west side, not the cliff on the east side. And this is what you see, scratched bedrock. And I was looking east, scratched bedrock, went over that 800-foot cliff and out 15 miles out into the plain. And by the way, they get a fair amount of precipitation here in the wintertime, and the scratches are still there. They have not weathered out, indicating the Ice Age was not that long ago. And this is a place that gets probably up in the upper 80s for high temperatures. And there's no way glaciers can occur in Glacier National Park. I mean, for the whole park being glaciated, and extending south down and through the Rocky Mountains and this area here, and out into the plains. And I'll show you some of the conditions needed to glaciate. And then you find other features across the earth, like here's what's called a striated pavement in the Sierra Mountains. So here's some of the erratic boulders lying from the melting of the ice. It polished the granite. I'm about 3,500 feet above sea level here. And you look at along the eastern Sierras, you see all these nice horseshoe-shaped moraines. This happens to be in the Wallowa Mountains. This is Wallowa Lake, over-deepened lake, like a fjord you see on the western Norway. And then, but what's that around it like this? Right here. That's a horseshoe-shaped moraine for a glacier that was coming out here. And glaciers in valleys a lot of times can over-deepen, forming, this is very deep in here. And then when you go down to level of the lake, there's the moraine, and there's a trees for scale. That moraine is 600 feet tall of debris coming out of the valley. And when you look at the moraine, it's glacial material rocks of all sizes in a finer grain matrix, typical of glaciated areas. And this is near Enterprise, Oregon, and they get up in the low 90s for high temperatures in the summer. You're going to have to cool the temperatures off probably at least 50 degrees Fahrenheit in the summertime to have glaciers or snow and ice that lasts from the winter through the summer to the next winter so it can build up. And then you have all these erratic boulders here and there along the plains. This is the famous Okotoks erratics, southwest of Calgary, Alberta. And this is a quartzite, by the way, very angular. It didn't roll down, and it certainly didn't come there from the Genesis flood runoff. The only way it can be there is by an iceberg and from a glacial river, because there's a train of these glacial erratics from Jasper, Canada, where you find the quartzite outcrops, in a narrow line. It goes southwest of Calgary and ends up at Cut Bank, Montana, or near Cut Bank, a little north. It's called the Okotoks Erratic Train. And this was formed by probably the runoff. See, glaciers have to melt. The last event in glaciations is a melting, so you're going to have a lot of water. And so you probably had a lot of glacial rivers, and this was probably formed between two ice sheets, the Laurentide ice sheet on the central and eastern Canada and the adjacent United States versus the Cordilleran ice sheet, which occurred over British Columbia and the Rocky Mountains and down the east slopes a little bit. So there was a narrow corridor there that was open for early in the Ice Age for man and animals to come across the Bering Land Bridge down through Alaska, down the east slopes of the Rockies to the southern United States, down into Central America and South America. That's how everything got here during the Ice Age. The woolly mammoth, Columbian mammoths, cave bears, saber-toothed tigers, all your typical Ice Age animals. And then here's some cool pictures from the Ice Age. This is called Bubble Rock. It's in Arcadia National Park in Maine. Now that's a really fantastic erratic. And here's one that from the Lake Missoula flood. This is southwest of Portland, Oregon, about 50 miles in the Willamette Valley. It's argillite, slightly metamorphic shale. This is rock you see all around Missoula. It's part of the Belt Supergroup. And the only way you can get, and look how, but this couldn't roll here during the Genesis flood. I've had friends tell me that they think it's all from the Genesis flood, by the way. That's why I'm saying that. I don't know whether I should defend that or not, but no argillite outcrops in the whole state of Oregon. The only way you can get this down here is by an iceberg in the Lake Missoula flood. And by the way, there's erratic boulders from Lake Missoula flood all through the Willamette Valley, hundreds of them. A guy from the 1935s made a plot of a couple hundred of them, dots all over the Willamette Valley, through the Columbia Gorge, even high up on the Columbia Gorge, because it was 1,000 feet deep through the Columbia Gorge, Lake Missoula flood. And of course, here's a picture of it, and Kevin did a great job explaining that, so I won't embellish any further. And here's the path of it from satellite. It's like an anastomosing stream that has channels like this that converge and diverge. And here's another cool picture from space. These are drumlins. That's associated with the Ice Age. These are formed by fast flows, ice streams. That's kind of a new discovery in the last 20 years. Fast ice flow streams that streamlines the bedrock into these lens-shaped features. And there's thousands of these drumlins all over the earth where it was glaciated. And guess where that's taken? Oops, I gave it away. Southern Puget Sound. LIDAR that takes away all that pesky biology that's on it that covers it up and shows you what the surface is like. It's a drumlin field all through Puget Sound. Cool picture. Anyway, the Ice Age was a real event, and here's the general locations of it. Notice that it didn't hit the lowlands of Alaska, only in the mountains. And they were in their models, and their climate models practically all glaciate the lowlands and the highlands of Alaska the same. But just all the mountains, mainly in Alaska, got glaciated. Now, the lowlands is where you find those woolly mammoths and horses and bisons, large bisons, special bisons that are extinct now, in the permafrost. And this is a schematic. It's not accurate over the western mountains, but a lot of the western mountains were glaciated. The Cascade Mountains were glaciated, much of the Rockies. Clear down to the San Francisco Mountains outside Flagstaff were glaciated. And in Europe and Asia, this is the general location of the ice sheet. Even the central mountains of Central mountains of Asia. And notice Siberia here. Just the mountains of Siberia were glaciated, but not the lowlands. And that's where you find the woolly mammoths in this area by the millions, estimated still in the permafrost, and mostly woolly mammoths. And a lot of the mountains were glaciated, the Alps, but other mountains were glaciated that are not shown. It's just a schematic. Okay, there was an ice age. We all have to explain it. Can mainstream scientists explain it? Well, if you go to a college course on the ice age, they make it sound like, yeah, give us a little cooling, presto, we got an ice age. They make it sound like it's pretty easy stuff. But we're going to take a look at that a little better. First of all, we got to know, how do you get an ice age? What are the requirements for an ice age? Well, there's generally 3. You got to have cooler summers because it's mainly solar radiation that melts ice and snow. Not temperature necessarily, but mainly solar radiation. And then, and we have a lot of it in the summertime in the mid and high latitudes. And that fact, that's what keeps the tilt of the earth is what keeps us from glaciating. Some people think if we had a perpetual spring with a vertical tilt of the Earth's axis, we'd have a universally warm climate. No, we couldn't melt the snow and ice in Alaska and Canada, and it'd slowly build up and push down. Like that Johnny Horton album that says, when it's springtime in Alaska, it's 40 below. Anyway, I don't know why I got off on that dog leg. Anyway, you got to have cooler summers, and you got to have greater snowfall, and it has to persist. You can't just get a climate change for 1 year. It's got to persist for many, many years. Talking about climate change, this is real climate change, not the little tiny bit that we're having for global warming now. And yes, it is small. I better not get off on that. I have a whole DVD on it. I can talk an hour on it. But anyway, the question is, how much cooling do we need? Well, a man decided to do a computer study, and what he did was he wanted to find out in Canada if he cooled the temperatures off by increments of 2 degrees centigrade. 2 degrees, he cooled it off, the average, which is 10 degrees centigrade, cooled it off to 8 degrees centigrade, to 6 degrees, so forth. And he wanted to find out where the 1-inch line from the winter snow lasted through the summer, so he can have the first year of an ice age, you see. And when he found out that he cooled it off to temperatures of minus 12 degrees centigrade, that's 20 degrees Fahrenheit, that's where his 1-inch line ended up, just up in there. But the ice went clear well south of the Great Lakes. By the way, it didn't move from Canada down to the United States. It formed, in the model I've developed, more or less in place. More or less in place. But it'll tend to move south because glaciers move by the slope of the surface. And that'll always be from north to south. So you'll find your scratched bedrocks going from north to south. Boy, how much do you need down in, say, Minneapolis? Well, Minneapolis averages 70 degrees Fahrenheit. That includes the high and the low. So the average is 70. So you'd have to cool it off to at least below freezing, would you not? But you have to go way below freezing because solar radiation is the main mechanism to melt snow and ice. How far? I read this research report in the journal Quaternary Research, and I found out where the lowlands of Antarctica, when do they start getting net melting when they warm up in their spring? Well, it's when they reach 14 degrees Fahrenheit. That's when you get net melting in Antarctica, the lowlands. 14 degrees Fahrenheit, because you have a powerful amount of sunlight. Well, if we applied that to Minneapolis, we'd have to cool the temperature off to, 56 degrees Fahrenheit. But I'm going to be more conservative and say we only need a summer temperature drop of 50 degrees to make it even. Round it off. 50 degrees Fahrenheit. Where are uniformitarian scientists who believe in present processes over millions of years, including climate, where are they going to get 50 degrees Fahrenheit cooling in the summer and to persist year after year for the snow and ice to stay there in Minneapolis? See the problem? Starting to get it? So, as a result, experts on the Ice Age will admit that the cause of the Ice Age is really unknown. Like J.K. Charlesworth, he wrote in the book, The Quaternary Era. Quaternary is another jargon for their Ice Age period. And this is on page 1532. It's a 1,700-page book on the Ice Age. You probably can't imagine anyone writing something like that. But I can, and I actually enjoyed reading it. And I didn't fall asleep too often. But he says towards the end, we get into the cause of these, after he's describing all this great stuff. Pleistocene is another buzzword or jargon for Ice Age. Pleistocene phenomenon have produced some great theories. By the way, they have 60 theories on the origin of the Ice Age. There's only one other aspect I know of that has more, I should call them hypotheses. Hypotheses is kind of an educated guess. A theory is a well-established hypothesis. And a lot of these aren't well-established, so there's actually more for the origin of the demise of the dinosaurs than there is for the Ice Age. There's over 100 hypotheses on the demise of the dinosaurs, which might give you a hint that maybe they really don't know. Anyway, it's produced an absolute riot of theories. I love his language, ranging from the great to so-so, no, ranging from the remotely possible to the mutually contradictory and the palpably inadequate. Now wait, that's 1957. Oh, this is modern times, and we know so much more now, do we not? Not really. Oops, went the wrong way. Let's go to something more recent. U.S. News and World Report, 1997, reported on the top 18 mysteries of science. One of them is what causes ice ages. But some of these mysteries are mysteries of their own making because they believe in evolution. Anyone notice that first mystery this there? Why should males exist? Well, see, in evolution, there should just be one sex that reproduces asexually. They can't figure out why there should be a male and a female, and they do research, write books every year, trying to figure out this great mystery. But that's where the Bible has the evidence hands down, because it simply says God made us in the beginning, male and female. Anyway, within that, it says, secular scientists has great difficulty explaining an ice age. We've been chewing on this problem for 30 or 40 years. Actually, it should be 130 to 140 years. It's a killer. It's embarrassing. And right here in Missoula, retired and I think late Professor David Alt wrote this book about Glacial Lake Missoula and its humongous floods. Although theories abound, no one really knows what causes ice ages. That was in 2001. And by the way, once they established there was one Lake Missoula flood, they had to have many. Because when you have many, it sounds more like business as usual, uniformitarianism. Well, I've found that there's a lot of evidence against multiple Lake Missoula floods. In fact, a guy did a PhD thesis. I don't think it was here at the University of Montana. I can't remember his name. I have quotes from him. But he went north of Missoula. And if there was multiple floods, by the way, they started with 40, and now they think there's about 90 of them. At the end of only their last ice age. Anyway, he went north of Missoula, and he expected, well, if you're going to have a pause in filling up Lake Missoula many times, you should find a surface, and it's going to have some channelized flow through it, because it's been exposed for maybe 40 or 50 years before Lake Missoula filled up and covered it. He went up there and drilled clear down to bedrock and found no, we call them in geology, unconformities. He found no unconformities, and he says right in his PhD thesis, this is evidence of only one flood. And my latest one I looked up, I haven't done this for many years, 2008. This is from the most widely read journal in the world called Nature. And they say perhaps the longest standing puzzle in earth science is what causes northern hemisphere ice sheets to come and go. So it's a puzzle. Can we explain it? Well, first of all, we got to fit it into where it occurs in earth history. Was it before the flood? Well, the flood was a lot of warm water. It'd melt it and destroy it, and we wouldn't have any evidence if there was one. Did it occur during the flood? Nah, it couldn't happen with all that warm water. Anyway, the most obvious place is to put it after the flood in a transitional climate to the present climate. Pre-flood. By the way, there's lots of evidence for a pre-flood warm earth. And I have a chapter in my book, in one of my books back there, explaining the pre-flood from the clues we have from geology, fossils, and the Bible. Anyway, the flood occurred, and then transitional climate to the present. So that suggests the possibility that maybe the aftermath of the flood caused the great climate change for an ice age. Well, let's check into that and think about it. Well, the flood, well, a lot of things happened in the flood. One thing that happened was a lot of volcanism. So after the flood, you'd have all this volcanic dust and aerosols. Aerosols are fine particles of dust, 1/millionth of a meter in diameter, called a micron, and it causes cooler summers over the land. It doesn't affect the ocean water, by the way. It'll cause cooler surface of the land, and we've observed this in the last couple hundred years from large volcanoes that go off. Mount St. Helens doesn't qualify as a large volcano, and it didn't affect the climate at all, except locally for a few days due to the ash clouds. But it's the large volcanoes like Tambora, Krakatoa, and others. So the second thing that happened during the flood, the fountains of the great deep and all this volcanism would warm the ocean water. The pre-flood ocean probably started warm because of the warm climate. And so all this volcanism would have continued to heat up that water. So after the flood waters are now in the current oceans. And that water would be warm from top to bottom, pole to pole. And this would add a huge amount of moisture because the warmer the water, the faster the evaporation, by a lot. For instance, at 86 degrees Fahrenheit, you can evaporate with all other variables the same, you can evaporate 7 times as much water into the atmosphere as you can with a temperature of 32 degrees Fahrenheit. 7 times. And by the way, compared to today's sea surface temperatures, the warm water would be especially effective in the mid and high latitudes compared to today. Much warmer ocean water up there, much more evaporation at high and mid latitudes to get caught in storms to dump on the cold land. That's kind of how it works. And the mechanism would persist, but wane with time. How's that? Well, we had a lot of post-flood volcanism. We know that too. I'm going to have a quote on that soon. That would continue to replenish these particles because they slowly fall out in anywhere from 1 to 10 years, depending on how high the volcano put particles up in the stratosphere. And then the ocean cools. You cool the ocean 3/4 by evaporation, which puts the water vapor in. It cools the sea surface temperature, cools and sinks, the water sinks. And also by contact between dry air coming from land, dry cooler air over the warmer water. So that's how you cool the ocean, and it has a time feature in it. And we can solve for time if we can make some assumptions on, say, the original temperature of the ocean, how much it'd have to cool before the ice age reaches a peak. And I've done all this stuff. But here's a few little, oops, I didn't want to do that. Let's see. Anyway, you had a lot of post-flood volcanism. We have these stratovolcanoes, 700 of them across the earth. Most of them are probably post-flood, probably not all of them. No one's ever done any research project on what can be from the flood and what are not. I actually believe Yellowstone volcano, which is a super volcano, actually went off late in the flood. I have demonstrated that from a research project to the southeast in the Wind River Valley. Anyway, here's kind of a schematic of how when you get this dust and aerosols, especially aerosols, it reflects some of the sunlight back to space, not reaching the ground, and these squiggly lines, yeah, that's right. The squiggly lines are the infrared radiation that is not stopped by the dust and aerosols, passes right through, reflects some of the sunlight back to space, cooling the continental areas. And Charlesworth acknowledges that we had a huge amount of volcanism in the Ice Age. Signs of Pleistocene, that's Ice Age volcanicity and earth movements, are visible in all parts of the world. So here's a general schematic, if I can get it moving. Oh no, it doesn't. Yeah, it's the wrong one. There's one that moves for you. Anyway, warm oceans at high latitude, lots of evaporation, clouds, aerosols, and clouds reflect a lot of sunlight back to space, cool the land, and you have lots of snow that falls on the cold land. That's kind of how it works. Okay. Whoops, I went too far there. So the next question is, how rapid was the Ice Age? Do we need 100,000 years or 90,000 for an ice age, like they believe in their time scale? Here's my evidence that it was really fast. This is it, Jenkins, indisputable proof that the ice age caught these people completely off guard. Anyway, I was able to time it. I won't go through the details. If you really want it, actually, the book that I published on this is out of print, but there's going to be a new one out, going through the details again. Anyway, I timed it to reach glacial maximum, and I used to see. There's no way to be accurate with these data I use, so I use minimums and maximums for this cooling equation. It's an equation to cool the ocean, and I got this is the range. The best estimate was about 500 years to reach glacial maximum, and then I had to estimate the average snow depth in the northern and southern hemisphere. The southern hemisphere would be mainly Antarctica. And I used ranges for the variables. Got a best estimate, about 2,300 feet on the average for northern hemisphere. And by the way, this varied a lot. New England probably had quite thick ice because it's closer to the warm ocean and the storm tracks. But in Montana and Alberta, Montana east of the divide, the ice was really thin because the Cypress Hills, which I showed you earlier, stuck up 300 feet above the ice. So it was really thin in Montana. In fact, there's one place that wasn't glaciated in northeast Montana and in southern Saskatchewan. It totally missed it, and it's not very high. It's called the Wood Mountain Plateau, if anyone's ever heard, and the Flaxville Plateaus. So it was quite variable. That's an average. Antarctica, about 4,000 feet. And by the way, the ice will melt quickly, about 10 meters a year on the edge. So using ranges for the variables, especially the reflectivity of the ice, which changes radically in a very short time scale. Best estimate, 70 years. It'll take more time for interior Canada, interior Scandinavia, about 200 times. So the total time is 700 years for an ice age. We don't need 90,000 years for an ice age. So here's a general little schematic. I assume the average ocean temperature is about 30 degrees centigrade, top to bottom, pole to pole. And when it cooled to 10 degrees centigrade, which is actually 6 degrees centigrade warmer than it is today, which is 4 degrees, that's when you reach glacial maximum. 5 time goes to the right. And then it cools more, and then this is where you deglaciate. Here's a more up-to-date figure on the average summer and winter temperature. Neglect that green line in there. That's the climate early in the Ice Age would be mild because you had warmer winters. See, here's your average. Yeah. Here's your average today for winter temperatures. Winters would be much warmer. Why? Because you had all that warm water. Warm water will also warm the continents in most areas. So the Ice Age would start slow in key areas only and then mushroom from there. And summers would be cooler, so you'd have little temperature difference between the seasons. And you know, the flora and the fauna of the Ice Age verifies this. It's called disharmonious association. You had animals that loved the cold next to animals that loved the warmth in the Ice Age sediments. This is called disharmonious association. The secular scientists are just flummoxed by this data. But the Ice Age was very dynamic. And that winters cooled. By the time you get to glacial maximum, in the end, it was actually well below today. And that's when the woolly mammoths and all those animals froze in the Arctic, Siberia, and so forth. Well, summers gradually warmed. And when winters become colder, you get less precipitation in the winter. So this would be the annual precipitation on the continents. You'd start with heavy precipitation early in the Ice Age, and where you didn't have ice, you'd have heavy rain, a lot of heavy rain. But towards the end of the Ice Age, you'd be drier than normal. And it's the dry period, right in here where you'd freeze those woolly mammoths, and they end up in windblown silt in Siberia and Alaska. So, was there more than one Ice Age? Well, I actually think there's 2 Ice Ages. One before the flood, and it was outside the Garden of Eden. And this is the Earth's first Ice Age. Thank you, Dan Letha, for this cartoon. And, you know, I got to explain this a little bit because some people have gotten insulted, I found out. You know, when God created man and woman at the beginning, their communication was perfect. You know, but when sin entered in, things don't quite work out that well. And men generally have clueless issues and women's sensitivity issues, to be very general only. Don't take that too far. But anyway, this group of scientists from the University of Edmonton in Alberta examined, they thought there were maybe anywhere from 3 to 6 ice ages in Alberta. But they re-examined all this material and published it in a journal called Geology, right there. And this is what they said about their area. Glacial reconstructions, notice this, commonly assume multiple glaciations. They assume them. So if they see some complications, like they see a glacial debris here and maybe sand above it and then maybe more glacial debris, they say, aha, there's evidence for 2 ice ages. But, you know, one ice age can do that by surges and melting back, surging again. So modern glaciology shows this can happen. But when they see these, they always assume multiple because they want multiple glaciations. By the way, on the continents, you mainly have evidence of mainly one, except in certain areas along the edges. where they have their evidence for 50 is from deep sea cores, coring and seeing variables in the deep sea cores, and that's where they get their 50 ice ages from the bottom of the ocean. So they assume a multiple glaciation hypothesis in all areas that contain a till cover, and that's a glacial debris. Will there be a future ice age? Well, remember, we're not out of the ice age period. Are any of you old enough to remember when from 1945 to 1975 about they predicted the new ice age was coming because we had global cooling? 30 years of global cooling when CO2 was going up like that. That should tell us a lot about global warming. There's a lot of natural processes in that, and those figures, which are rather, they're estimates. The temperature figures have some errors in them. Well, we are still in the cycle. The last ice age melted 10,000 years ago. See, that's why they think the new one's coming, and they thought it was approaching in the 1970s. And by the way, there's 3 books that I have talking about the new ice age is coming. Can we survive it? There'll be drought. And of course, they just erase all that stuff and say, oh, global warming, now drought, oh. Anyway, and then in the New York Times, Daniel Grossman said, if the past is any indication, the Earth is at the end of another such warm period, that's the one we're in right now, poised to descend into a new ice age. Now, we believe everything we read in newspapers, do we not? Especially the New York Times. Now, I don't hardly believe anything I read in the newspapers. But anyway, the rainbow was a promise that there'll never be another global flood. And if there won't be, and the flood caused the ice age, there'll never be another ice age either, because the global flood only happened once. And by the way, with this ice age model, you can explain a lot of other things. And here's a list of them. I won't go through these because I don't have time. These would be the bonus features if we had another half hour. But my resources out there go through these things. And I will quickly summarize because I gotta go past all the bonus features I would normally talk about. So here's a summary. The Ice Age was a real event not that long ago. It was a real event. We have to explain it, so do they. And it's a major mystery for evolutionary Earth scientists. Noah's flood caused a transitional climate for an ice age. The Ice Age lasted only 700 years. We don't need 100,000 years for an ice age. There was only one ice age. Only the Bible explains the ice age because of the flood. And there will be no future ice age. So some concluding thoughts. Creations have a viable mechanism for the last major event in Earth history, while evolutionary scientists are far from a solution. Then why should we believe them for all those older hypotheses? The origin of the trilobites, the origin of the dinosaurs, the demise of the dinosaurs. There's thousands of these just so stories. Just so stories. If anyone knows the origins of the just so stories, I'm not going to get on that. But anyway, they're just storytelling, those things. Another concluding thought. The Ice Age is an example of what can be done with hundreds of other earth science challenges to the Bible. Now, speaking of earth science challenges, we have answers to many of them, but we don't have answers for a lot of them too. And the reason I know this is because I keep up, or attempt to keep up, with about 50 earth science journals in the Montana State University Library. So there's lots of challenges, and we have a lot of answers, but we don't have answers for something, mainly because we haven't got enough creation scientists doing research on these things. And as I tell people, I still have 500 years worth of research left to go. Okay, and here's another one. Time is not a side issue. People are really challenged by our short time scale. But it's not a side issue. I discovered that it's key to solving these issues. A younger time scale is sometimes the key to solving major mysteries that have lasted 150 years. How so? Well, they know that volcanoes will cool, But when they stretch everything out to 100,000 years, each of these volcanoes that go off only last maybe a couple of years and are not significant. But if all that volcanism that we see, like the 700 stratovolcanoes, are telescoped within several hundred years, it becomes a powerful mechanism to cool the continents. The short time scale is key to solving this mystery. Another concluding thought, the Ice Age is based on the flood. Therefore, the flood, one of the most despised events by the culture, is a real event of the past. Therefore, it is easy to believe the whole Bible, which tells us how to live here on earth and how to go to heaven. Well, how does that last one look like? Well, I think this one verse summarizes it all. Romans 10:9, how to get to heaven. If you confess with your mouth that Jesus is Lord, and believe in your heart that God raised him from the dead, you will be saved. So that's a quickie, how you get to heaven. Anyway, if you're interested in resources, here's the main book that I have, Frozen in Time, The Woolly Mammoth, the Ice Age, and the Bible. It focuses especially on the woolly mammoth, but it talks about both. And I got a DVD on the Ice Age. Now, this isn't your ordinary DVDs. Same with the Lake Missoula, Great Missoula Flood and the runoff DVDs. These were filmed out in the field showing you these features. It's just not a talking head. It's 90 to 100 minutes worth showing you the features as we go of the Ice Age. Mainly in Montana and Wyoming and Oregon is where I filmed, these things were filmed. And if you really want to get into ice cores, this is an in-depth book called The Frozen Record. I got a lot of resources on the Ice Age. I'm only going to keynote a few of them. And of course, what is very big deal around here is the Missoula flood controversy. I emphasize that controversy and how we can use those landforms, as Kevin showed, for evidence of the Genesis flood in this book right here. And by the way, this picture is from areas you showed, the potholes area. And this was at a different time when the algae turned the water green. And so the green and the black background really show beautiful. I think this is in the fall. And of course, there's that Great Missoula Flood DVD. And I've written 5 children's books. And this is teaching about the Ice Age in a fun story, Life in the Great Ice Age. And we wrote a sequel focusing, this is my wife and I did this together, uncovering the mysterious woolly mammoth, focusing mainly on the woolly mammoths in the Ice Age. And I wrote the weather book, which has a different cover. It's now a homeschool course for all grades. There's 3 levels in it. They made me update it, called the New Weather Book. So it's a homeschool course if you're interested in that. And I'm going to leave you with one of my favorite verses about this whole area. Your faith should not rest on the wisdom of men. That's evolution, uniformitarianism, deep time, but on the power of God. God has the power. And here's some of those websites. You get a lot of free data. I mean, say you get questioned by people. What about carbon-14? What about, how did Cain get his wife? Things like that. Look on the websites. There's a search engine, like creation.com has over 12,000 articles that you can get free and get lots of data. If you have a term paper, young people, on a subject, you can get your data there. So I thank you.